in this video, we're going to solve combined gas law, which is the formula of P1B1 over T1 equals P2B2 over T2. So, first thing we need to do is calculate the volume of a gas at STP if 500 cubic centimeter of the gas are collected at 27 degrees and 96 kilopascal. So let's begin. This is problem number 1. Problem number 1. So problem number 1, we have a pressure 1 here. Pressure 1 has a 96 kilopascal. So pressure 1 is equals to 96 kilopascal. Standard temperature, which means STP. So the P2 is 101.325 kilopascal. And then the volume 1, which is 500 cubic centimeter. Volume 1, 500 cubic centimeter. And then the volume 2, which is unknown. Okay. Volume 2 is unknown. Okay, calculate the volume also. And temperature 1, which is temperature 1 here is equals to 27 degrees Celsius. So 27 degrees Celsius plus 273 Kelvin, which is 300 Kelvin. And temperature 2, which is STP at 273 Kelvin. Okay, in the solution, okay, use again the formula. So P1B1 over T1 is equals to P2B2 over T2. So you need to cross multiply again. So P1B1 times T2 is equals to P2B2 times T1. So we need to divide both sides by P2 and T1. So cancel out. So P1 B1 T2 over P2 T1 is equals to B2. Okay, the left is B2, right? Here, bring down. So in pressure 1, we have a 96 kilopascal. 96 kilopascal times the volume 1, which is 500 cubic centimeter here. The volume 1 is 500 cubic centimeter times the temperature 2, which is 273 Kelvin. Okay, 273 Kelvin divided by the pressure 2, which is 101.325 kilopascal at STP. 101.325 kilopascal. And then the last one is temperature 1, which is 300 Kelvin here. 300 Kelvin is equals to volume 2. So volume 2, cancel out kilopascal, and the Kelvin is cancelled. So the left is volume, which is cubic centimeter. So 96 times 500 divided by times 273 divided by 101.325 times 300 is equals to 431 cubic centimeter. So 431 cubic centimeter. Okay. That's all. That is your final answer. 96. Alright, how about in problem number 2? If the gas occupies a volume of 100 cubic centimeter at a pressure of 101.3 kilopascal and 27 degrees Celsius, what volume will the gas occupy at 120 kilopascal and 50 degrees Celsius? So pressure 1 here is is 101.3. So 101.325 kilopascal. And volume 1, which is 100 cubic centimeter here, 100 cubic centimeter. Volume as a 100 cubic centimeter. Volume 1. And the temperature 1, which is 27 degrees Celsius plus 273 Kelvin is equals 300 Kelvin. And then the pressure 2, which is 120 kilopascal, 120 kilopascal. And how about the volume 2? The volume 2 is unknown. And the temperature 2 is equals to 50 degrees Celsius here, 50 degrees Celsius plus 273 Kelvin is equals to 323 Kelvin. Okay, the solution again. Let's use again the formula. P1 B1 over T1 equals P2 B2 over T2. So P1 B1 T2, you need to cross multiply. So P2 B2 and T1. Okay, divide both sides by P2 and T1. Here P2 and T1. So you need to cancel here. So the left is the volume 2. So P1 B1 T2 over P2 T1. So volume 2 is equals to, what is the value of pressure 1, which is 101.325 kilopascal? 101.325 kilopascal times the volume 1, which is 100 cubic centimeter. 100 cubic centimeter. And how about in temperature 2, which is 323 Kelvin? Okay, 323 Kelvin. And how about in pressure 2? The pressure 2 is 120 kilopascal. So 120 kilopascal times the temperature 1, which is 300 Kelvin. Okay, 300 Kelvin. So volume 2 is equals to 101.325 times 100 times 323 divided by 120 times 300 is equals to 90.91 cubic centimeter. Okay, so you need to cancel out kilopascal, Kelvin here, and the left is cubic centimeter, that's their unit. Right, let's continue in idea gas law. Please like and subscribe.